Hi everyone. So this is regarding your this video is related to your assignment number 8, which will be uploaded soon. So the first question is again, about the computation of what is column space of A transpose, null space of A, column space of A, and null space of A transpose. You have given a matrix. So what is the matrix? 2, 1, 5. Let us write it carefully. 4, 2, 10, 6, 4, 18, 10, 5, 25, 2, 1, 5. Now, so let us apply the row operations. I will not write row operations. I will just directly do it. Now it's your job to figure out row operations, right? I mean, because you can do now. Okay. 1, this is 5, 10, 18, 25, 5. So now next row operations. I told you always circle the pivotals. 3 into 5 is 15, 16, 17, 18. So 3 will come. Well, this you can rewrite as like this. 1, 0, 0, 2, 0, 0, 1, 1, 0, 0, 0, 0, 0. It means the corresponding pivot elements, the corresponding columns will be linearly independent, right? So it means column space is what? Span of these two columns. The first one, which is what? The first column is 2, 1, 5. And what is the third column? 6, 4, 8, right? Oh, I mean 18. That's all. Now, what is the null space? The same matrix will help you to find null space, right? What is null space, guys? This is all x equal to x1, x2, x3, x4, x5, right? In R5, such that this matrix AX equal to 0. So I have to solve the same augmented matrix. Just a second, guys. Yeah, so you have to solve the same augmented matrix, which will if give you, if you write it properly, x3 is equals to 0. Okay, very nice. That's fun. And x1 you can write as minus 2x2 minus 5x4. I am omitting x3 because x3 is 0 minus x5. So, you got your, what is your null space? So, your null space is minus 2x2 minus 5x4 minus x5 x2. Good morning, sir. Sir, I'm recording video right now. So, yeah, I will upload when to upload? अच्छा तो आप भी वो असाइनमेंट कर दीजिएगा कहीं वो लास्ट टाइम की तरह Yes. So, okay, sir, then I will record and immediately upload. So x2 and x3 is 0, right, guys? And then what is x4? x4 is x4, x5. Sorry for the digression. x2, x4. The digression is, yeah, I started talking in between of, recording. So, now you can write it as span of, what span? Minus 2, 0. Oh, no, no, no. x2 if I take common, what I will get? Minus 2, 1, 0, 0, 0. Then minus 5, 0, 0, 0, 1. Oh, that's wrong, right? I can do this here so that I don't have to drop too many things. So minus 5, 0, 0, 1, 0. These are the three vectors, and you can see these are clearly linearly independent. Can you see why it is clearly? Because see, here you have a non-zero number, or you take x1 into first, x2 into second, and x3 into third, and you will get that vector above written, and all xi's has to be 0 from that, right? From here, if you rather write like this x2 into, say, this is v1 plus x of 5 into v2, say this is v2, like the combination, you can do that thing. So the dimension is 3, of course. Similarly, you have to do for it a transpose. I think you can do. I'm skipping that. Just take the transpose of the matrix and do things. That's all. So I'm skipping B part also because like we have given you enough examples. Let me do the problem number 2. So you have some real numbers A, B, C, D. So that AB minus, these are real numbers, okay? AB minus AD, I think AD, yeah. AD minus BC. So AD minus BC is non-zero, okay? Now what you have to prove? You have to prove, show that this ABCD is a basis of R2. This is a very fun example. Now, there are many ways to do that. So the way I am right now having in my mind, we know that the dimension of R2 over real numbers is what? 2. Why, guys? Because R2 you can write like x1, x2, such that x1, x2 belongs to R, and this is nothing but span of 1, 0, 0, 1, right? And these are linearly independent, clearly, right? You consider a combination x1 into first vector plus x2 into second vector, what you get x1, x2, and you put it equal to 0, what you get x1 equal to 0, x2 equal to 0. It means 1, 0 and 0, 1 are linearly independent, right? So, yeah. So dimension is 2. So by that theorem I told you, a maximal linearly independent subset is also a basis, right? Equivalent condition. It is sufficient to show. It is sufficient to show this set of two vectors is linearly independent, right? Any one condition, or you show span, it doesn't matter. Any one condition. So let us show these are linearly independent. So how we show something linearly independent? We always consider the, we write it like column wise, and then we apply some row operations. See, the row operation should be something like this. AD minus BC should come there, right? So if I apply R1, R2 changes to or something like that. Mm, let's try to make this B0, okay? So R2, by the way, there is a catch. Let me do that first observation. So let us call this matrix A. Note that what you have given, AD minus BC is non-zero, okay? So let us analyze. Can you know what I want to do is or let me think. Yeah, I can actually do like this. So imagine if A is equals to B is equals to 0. What you will get, guys? AD minus BC is equals to 0. So not possible, right? Not possible. Number one observation. So simultaneously, what I'm saying, simultaneously both of them cannot be 0. So case 1. If B is 0, definitely A has to be non-zero, right? Okay. So then A becomes like this. A, C, 0, D, right? Can D be 0? So if D is 0, what you will get? B is 0, D is 0. So AD minus BC will be 0. So this implies, oh, D is also non-zero. So what you get here, this is a non-zero element in this case. This is also a non-zero element in this case. So what is the rank of A, guys? Rank of A is 2. This implies A is invertible. Or this implies two pivot elements you have now. I mean, I don't need to do anything further. So two pivot elements you have. So this implies what it implies like, okay, so this, I mean, both of the columns are linearly independent. So this implies why I forgot, I don't have to show invertibility and all. Okay, so A, B, comma, C, D, just because you have two pivotals. So these are linearly independent, right? So this is the case one. So what condition I have taken? If B is 0. So case 2. If B is non-zero. So if B is no, 0, then A has to be non-zero, right? But if B is non-zero, there are two possibilities, right? A can be 0 or A cannot be 0. So let us determine these possibilities. So if A is 0, let us see. So here you have 0, here you have B, here you have C, here you have, no, something wrong, right? No, nothing wrong. So here you have C, here you have D, right? Yes. Now, question is, can C be 0? Can C be 0? So say if C is 0, so what is AD minus BC? Note that A is 0, so this will become 0. So not possible. So this is non-zero, this is non-zero, right? So when you consider, vector, when you see if these are linearly independent or not, so what you have to do? So you will consider some C1, 0, B plus C2, C, D. This has to be 0, 0. Again, by the same logic, I'm just repeating above. You will get, since C is non-zero, so C2 is 0, and then you will get C1 is also 0. Well, in this case also, you get these vectors. What vectors? A, B, C, D are linearly independent. So now it's better to analyze case by case always. Now let us come to this case if A is non-zero. Okay. So again you have A, B, C, D. So what is the case? A and B both are non-zero. A is not equal to 0, B is not equal to 0. Now you can apply a row operation. What will be the row operation? R2 changes to. See, I cannot initially apply this row operation. You cannot make B 0, right? Because you don't know what about A and B. And while applying row operation, when you multiply some row with something, you cannot multiply with 0. That's why it makes sense to consider these kind of cases. Okay. So in this case, R2 changes to what we will do? We'll do A times row 2 minus B times row 1. Okay, let us see what we get. So this matrix will become similar to A and C, C. Here you have 0, of course. Here you have AD, right? Minus BC. Wow, what a fun example. Rank is again 2, right? Two pivotals. So this implies AB, comma CD. These are linearly independent. Sorry for writing LI, I am lazy, writing it fully. Okay, so let us proceed to the next problem. So I hope you understood this. Problem number um, third. So what you have given, you have a vector space over R with two bases. So let us call it B is V1 to VD, and you're, oh my God, I don't like this notation. It's okay. B prime is V1 prime, comma, VD prime. So you have two bases. Okay. So if A is your transition matrix, so okay, by the way, transition matrix, or change of basis matrix. These are one and the same thing, okay? So sir is given that A is your transition matrix from basically where to where? From B to B prime. So this is the notation I like, whatever you want to write here. V maybe, because it's of the vector space V. Then we have to show some things. A is invertible, the transition matrix from B prime to B will be given by A inverse, and then you have some third basis, something happening, okay? So let us see what we can do. So transition matrix as in, since these two are bases, right? So this B is contained in definitely span of B prime, which is your V. So for each I in 1, 2, D, there will be some scalars, right? There exists some scalars, so however you want to call them, that's your choice. I will call them like that. C, um, maybe like this, or maybe like another. I'm not sure. Let me just think how I want to call them. Yeah, maybe like this. Yeah, maybe like this. I don't know. So CI1, CI2, CID in R. This is happening for every I such that VI you can write as what? VI you can write as CI1, okay? V1 prime plus CI2, V2 prime, okay? Plus dot CID VD prime. So if you see this is not one equation. This is happening for every I in 1, 2, D, right? So you have this matrix, right? So this A is basically this matrix. So what you do is you write, this is row wise scalar, you write it column wise. So first you will write for C1, 1, C1, 2. So yeah, better to change it to, I mean, doesn't matter. C1, 2. These are some scalars, right? C1D. And then what you have here? This is C2, 1, right? So these are I vectors. So yeah, I'm writing scalars like column wise. That's how you have defined these matrices. 2, 2. C. Yeah, you may not be happy with my notation because it doesn't look like an n cross n matrix entries. It looks like an, transposed version, but it's fine, na? These are symbols. So what you will get here? CD1, CD2, CDD. So this is your A. Okay. Now, so you can call this equation whatever is this all information. Okay. what I was saying, just a second. Yeah. So this is your A matrix. Now let us look for the matrix from B to B prime, B prime to B. So let us call A prime to be the matrix from B prime to B. So now B prime vector you will express as that. So similarly, if you write the same language what I'm writing, you can write like this. V some J prime can be written as some B J I L1 V1 plus B J 2 V2 plus dot 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 plus B J D V D. This is happening for every J in 1, 2, dot 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 D. This is, let's say, and this will give you a matrix, right? So let me, do my work easy. Let me copy this matrix, Control plus C, and let me paste here, and let me just, change all of my C to all C to D, right? B. Sorry, B, 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 B here, B here, B here, B here, B here. Okay. Now, this is my A prime, right? So I need to show that A is invertible. And if you look for the B part, I have to show something more. What I have to show is, yeah, the transition matrix from B to B prime is given by A inverse. So what I will show is A into A prime is equals to A prime into A. This is nothing but this is your identity matrix of order n cross n. Hence, I am done, right? So let us see what is A into A prime. Yeah, we have to write a general entry, okay? So let us say call its general entry is some Aij, and let us say its call its general entry is some Aij prime. Okay? So when you do a matrix multiplication, right, you have to do matrix multiplication. So systematically write the terms, okay? We should not skip anything here. So this will be summation k is from 1 to what? 1 to what? D A I K A K J prime, right? This will be the ijth entry of AA prime. Now let us put what is this is D cross D. Now let us put what is AIK and all. Okay. So AIK means the first A matrix ith row kth column. So this is for example second row. This is second row, second column, second row, first column, right? So what it would be? CKI, right? And what this would be? B J what? BJ K. Correct? These are the entries. CKI BJK. Now that's what we have to analyze now. What are these entries? Okay? This is a D cross D matrix. And if you want to call the entry of this by some different letter, you can call it eta, ij, or zeta, whatever this is. So to show what you have to show, ij is equals to what it is equal to. We have to show that this is equal to 1 if I equal to j and 0 if I is not equal to j. That's all. Now let us see how we can show this. Okay? We have to use these two equations. Oh, I haven't called this double star. Okay? So let us see what I can do. So now, this vi, this vector vi, what you can do, You can substitute these VI's in double star, right? So what you will get is, let me copy this again, so that my some work will be easy. Yeah, anyway, let's see. And I think I should copy differently. Let me see. Yeah, first I'm starting with maybe, so this I have, and another thing what I have is D. Another thing what we have is this equation. Let me copy this also, so it will be helpful now. Control plus C, and so these two equations we have, right? This is VI we have written, and this is VT prime, right? Yes. So let us substitute this prime value here. So what it would be? This is equal to, if you see, this will be, this is what? I1, correct. So CI1, let us substitute the V1 prime's value, okay? So meaning BJ1 V1 plus B, sorry, we are substituting what? 1. So 1, 1, 2, V2 plus dot plus B. This is for every j equal to 1, 2, what? N, na? Oh, sorry, D. So I'm just using it for 1. So I'm putting j equal to 1. This is not very hard. This is just fun exercises. Plus, similarly, CI2, what we will do? The 2, 1. V, 2, 1, V1, 2, 2, V2 plus dot B, 2D, VD. See, now it will just matter, collecting terms together, and you will see the magic. C, oh, ID. Yeah. What was the prime's value? So this into this I am substituting for D. So B, D1, V1 plus B, D2, V2, dot, B, D, D, VD. Very nice. What we will do? We will collect V1 terms of V1, terms of V2, terms of, on like that. So Vi. So what will be the coefficients of V1? Let us see. So coefficient of V1 will be Ci1 B1 1 plus Ci2 B2 1 plus, you see something happening, plus dot plus Ci what? D B D1. Correct? Now let me just see AIK if I have written correct. So if it is AIK, ith row, kth column, second row, say third column. 3 2. Yeah, flipped. No, we flipped CJK. Yes, this is correct. Something I was like some scalar if I have, written badly. Anyway, doesn't matter. Plus, similarly, the other B21. So, what will happen for the B21? So, this will be V2. The coefficients of V2, Ci1, B12 plus Ci2, B22 plus dot 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 plus Ci D BD2, right? Very nice. V2. And then finally you have to sum for the last one. I mean the coefficients of VD. I will tell you what will happen. So this is happening for every I, right? I we are not wearing currently. But yeah, we will vary third I also. So what will happen guys? So um see the coefficient properly I1 B1D plus C I2 Ci2 B2D plus correct dot 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 CID BDD. See, you have to be very careful while writing this. And nothing, it's just a matter of how properly things you are writing. Okay? Now, let us compute these things. For we have to see EIJ, na? So for I equal to J. So for I equal to J. Okay? What we have to show? To show EII is 0. So what is EII? Let's copy from here. So this is your EII. I mean, I will copy this expression and control plus C. This is control plus V. So II. So this is your EII. This J also becomes now I. Right? Okay, now let us see what it is. We are almost, near. So let us call this equation triangle. So put, no, how to say? See the coefficient of VI. So let me copy this, okay? Control plus C. And here control plus V. I want to write this in some different manner. Tell me if this is right or wrong. VI I want to take other side, okay? So if I take VI on that side, so first write the corresponding term for ith place. So for ith place, meaning VI is here, okay? So you will have I is there, okay? Note that. So C I, right? B 1 I, right? This will be 1, right? Yeah, this will be 1 plus C I. So this 2 I'm replacing with I, right? So C I 2 B 2 I plus dot 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 plus C ID BDI minus 1 because you have taken that VI that side plus dot dot dot, the final term, this one. And this is all 0. Note that V1, V2, Vd. What are these? Are linearly independent. So what you get? So all these scalars are zero, right? So in particular, so all these scalars, if you see here in this expression, so this implies all scalars in above equation are zero. So in particular, if you see the coefficient of Vi, coefficient or you got it now? What I mean by coefficient? Coefficient of Vi is 0. So what it tells you? Ci1 V1I plus Ci2 V2I plus dot 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 CID BDI equal to 1. Guys, what is this? This is nothing but your C, you know, um, yeah, this is nothing but your xi I, right? So xi I is 1. So similarly, if I is equals to j, okay? Some index here and there if it happened, that's the idea. Sometimes some index mistake can happen. So this is for, let me see if everything is fine here. Oh no, there is some difference. It's okay, we can change that. And similarly, what will be A prime, guys? A prime will be summation, you know, let me change, because I am proving for A prime A is identity rather than A prime here. Yeah, that's what. It's fine. So what is A prime? This will be similarly like the calculations we have done. So the k is from 1 to d. Now B, J, K, C, K, I. Let us call this xi, uh, you know, xi I, J for the moment because I am proving this as one. So if you see now, this is your xi I, right? What is this? If you want to expand, so this is exactly your xi I. So what you have proved, xi I is 1. Okay? Now, and other coefficients of Vj's for j not equal to I, right? J should not be I there, right? So if you observe, those coefficients are just xi I, j. So that will be 0. So what you have proved here is A prime A is identity matrix of order n. Similarly, what we have done, we have expressed everything in terms of VIs, right? Similarly, if you express everything in terms of VJs, similarly using the linear independence, what you will get is A prime is identity n. The coefficients will become, the entry of the matrix A into A prime. That's the fun part here. So that's how you have to proceed. That's all. Not that this is what? Xi, If you see, this is, this is I, 1. Correct? See here the expression. This is your, okay. This is here. I can change it. BIKCK. BIKCK. That's all you have to do. So similarly, so it's amount to expressing one in terms of another. So you will get these are. So what this implies? A prime is actually A inverse. That is your B part, and A is invertible in particular. That's what you have to do in this problem. And what is the C part? C part is not that very hard. C part is you have another basis, B double prime. This is again an exercise of matrix multiplication. So I will leave up to you guys to solve this. So this is some another basis from B prime to B double prime. Okay. And what you are saying, so you have a matrix from B to B prime, you're calling it A. You have a matrix from B prime to B double prime, you're calling it A prime. So you will get a matrix from B to B double prime using that. And normally on the compute, you can compute also. Compute it normally. What you should get, say this is A double prime. A double prime must be A prime into A. That's all you have to do. Shall I do? I can do. So I will do this bit quickly. So what is B? B is V1, VD. What is B prime? V1 prime, VD prime. And what is hmm, B double prime? V1 prime. This is all matrix multiplication if you see. So now you can express these Vi in terms of, these Vi primes in this fashion. So K is from 1 to D. I can name indices in scalars as I want. So C, I want to name like them like this. So of course V K will vary. So rather than above, I have named it in the reverse manner, right? It causes always problem. I mean not problem. It's just you have to be very careful. So I will fix the second component now. K. What? I. Hmm. Let us see. This will be C1, 1, C1, 2. No, no, no. Second component I want to fix. Ki. Now, similarly, Vi prime you can express as summation k is from 1 to, you know, some D. If you're not happy with k, you can change k to L. Some CB, okay, L, and this is, sorry, and we should also change this index, okay? It's better to use different symbols. Um, L, J, V, J, no, no, VL double prime. Whatever I have written, I'm, just writing in long, 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 not writing in those long equations. Similarly, you can express Vi also as, you know, some M from 1 to D, some scalars, let me call by some alpha symbol, okay? Alpha So this is your M I V N double prime, right? That's the matrix from this is correspond to B to B double prime, right? Okay. Now this is 1, 2. Okay. What you have to do is substitute 2 in 1. Okay. Substitute 2 in 1. Show that. You know, alpha mi matches with those scalars using matrix multiplication. I mean, what I mean is, so if you look at A, what will be the A matrix? A matrix will be CIK, right? This is the A matrix. Okay. What will be A prime? That will be B, J, L. And what is A double prime? By the what is A into A prime? This is summation. I is from your whatever you want, some N is from 1 to D. C, I, if you are writing ijth entry, then correspondingly you can write N, B, N, L. So A prime will be this matrix. Alpha, am I right? I am changing now. Yeah, something like this. Now, just you have to show that this alpha in is same as Cin. So what you will do? You will use all these three equations, you will write everything in terms of anything you want, okay? Maybe the better would be VIs. I mean, I'm not saying it would be better. Maybe the better would be VIs or better would be VL primes. Everything you will express in either VI primes, either VI double primes, or either VIs. And using the linear independence, we will got that these scalars are, you know, these two things are equal, like we have done above. So this I will leave as an exercise. Exercise. Essentially, this is the idea. There's nothing much. Okay. Now the fourth problem is easy. What we have to do, we have to again we have to find these this matrix transition matrix from B to B prime. So we have given some basis of R2. So I will do A part, B part you guys can do similarly. So A is 0, 1. First also check also that these are bases or not. If you see, I mean, I can fool you. I can give you something which are not bases. Anyway, these are bases. So now 0, 1 you have to express how? In terms of this. So C1, 1, 1 plus C1, 2, whatever you want to call, however, 1, 1, C1, 2, 1, 0. So you can, clearly, and another, you have to express 1, 0 also in this form. Say C2, 1, 1, 1, C2, 2, 1, 0. Solve these equations, what you will get? C1, 1 plus C1, 2 is equals to 0. And from second C1, 1, 0. Is weird. Let me see again. Oh, nothing is weird, I guess. So this is what you have. And 0, 1 you want to express, right? Yeah. This will be C11, C12, and this will be C11. Oh, correct only. And this is C21 plus C22, and this is C21. So C21 is 0, then C22 has to be 1, and here C11 is 1, then C11 is 1, then C12 has to be minus 1, right? Yes. So what is your matrix, guys? The A matrix is just you write these scalars vertically. C11, C12, C21, C22, like this. So 1 minus 1, right? And 0, 0, 1. That's all. That's all what you have to do. So I will urge you guys to do the part B. It's same because nothing is, different there. So let us see, do the question number 5 now. So I've given a linear transformation from R3 to R3, which is given by a matrix with the basis with respect to the standard basis. So basically, they are saying T1. Okay, what is the matrix first of all? So this is the matrix with respect to the standard basis E1, E2, E3. You will learn what it is if you haven't seen till now in class. So this is 0, 1, 0, 1, 0, 0, 0, 0, 1. By the way, E1 you know what is E1, 1, 0, 0. E2 you know what is 0, 1, 0. And E3 you know what is 0, 0, 1. So what you have given is effectively, once you have learned the definition of matrix of linear transformation, T of E1 you have given E2, T of E2 you have given E1, and T of E3 you have given, oh wow, E3 only. Okay. Now what you have to do? You have to find the basics matrix of this linear transformation with a weird basis. So that weird basis is this. 1, 1, 1, 0, 0, 1. And with respect to, yeah, this basis to this basis only. Okay. So this is also from E1, E2, E3 to E1, E2, E3. I mean, you can avoid that upper B if you want. 1 minus 1 0. First of all, you should always check if this is a basis, whatever is given to you. I'm not checking that, I'm assuming that this is a basis. So you can see there will be a problem if if it won't be a basis. Okay, so now let us first see what is T of 1 1 1. So if you apply the linear transformation, this is nothing but T of E1 plus T of E2 plus T of E3, right? So what it is, this is what? 1 into E1 plus 1 into E2 plus 1 into E3. So E1 was E2, E2 was E1, E3 was E3. So this is nothing but 1, 1, 1. Okay, very nice. So this you can write as 1 into 1, 1, 1 plus 0 into 0, 0, 1 plus 0 into 1 minus 1, 0. Okay? Now, similarly, T of 0, 0, 1. This is T of E2, right? This is 1, 0, 0 if I'm not wrong. है T of 1, 0, 0. That was the definition if I'm not wrong. Yeah, E2 goes to E1. Now, how will you write as linear combination of these three vectors? You can see if I do this. 1 into 1, 1, 1. Okay. Minus 0, 0, 1. So this will subtract this one and give you here 0. That one will remain 1. This one will remain 1. And if you add maybe, yeah, this we have to see how you can write it as linear combination of these three vectors. It's not very hard to see. So let us write A into 1, 1, 1 plus B into 0, 0, 1 plus C into 1 minus 1, 0 and construct the equations. So what you will get is A plus C equal to 1. Okay. and A plus A minus C, right? A minus C equal to 0 and A plus B equal to 0. Okay. So A is equals to C. Okay, fine. And A is equals to, and B is equals to minus A. Okay. So this becomes something like this, right? So A 1, 1, 1 minus A 0, 0, 1. And then you have C is also A, right? Yeah. Yeah, so I think just take A equal to 1 in particular. So what you will get 1, 1, 1, 1. Oh no, let us properly solve it, huh? I have done a mistake. I don't know why sometimes I'm very lazy in solving. Let us solve this equation like we usually do. I always like metrics. 1, 1, 1, 0, 0, 1, 1 minus 1, 0, 1, 0, 0. Now let us solve 1, 0, 1. I will simplify it 0, 0, minus 2, 0, 1, minus 1. Okay, 1, 0, 0. Okay, so what you will get here definitely this minus 2 into C is 0. So this implies C is 0. You don't need C. So there's some calculation mistakes. And from the third one you will get, oh, something is wrong again. Oh my God, what I'm doing? 1, 0, 0. No, nothing is wrong. I'm just confusing myself. So from the second equation, second row, you will get C equal to 0. Okay. And you have A plus C equal to 1 for the first one. And you have B minus C equal to 0 from third one. That's weird. B is 0. Okay. A is 0, B is 0. And oh, I'm an idiot, right? No, no, I'm not an idiot. Something wrong I'm doing. It seems my brain is not working. Let us see how we can write 100 as span of these vectors. So to consider this way, 1, 1, 1, 0, 1, 1, minus 1, 0, right? 1, 0, 0. Okay. Now, what this give us? C1 plus C2, C3 equal to 1. Okay. And C1 minus 3, 3 equal to 1. Yeah, 0. So C1 equal to C3, that was correct only. I don't know why I get confused. C1 equal to C3 equal to 1 by 2. And what is B? C2. So C2 is equals to minus C1. Ah, correct only, no? So C2 is equals to minus 1 by 2. Fine. So, yeah. So what we get is 100 is, so there is no error. I don't know. I was doing some calculation mistakes. So this is 100. You can express it as 1 by 2, 1, 1, 1 minus 1 by 2, 0, 0, 1 plus 1 by 2, 1 minus 1, 0. That's all. Now, similarly, you have to do the third vector also. So, what was the third vector? So, T of, what was it? 1 minus 1, 0. So, 1 minus 1, 0. You can write it as T of E1 minus E2, right? This is T of E1 minus T of E2. So if you see, this is E1, right? So it is E2 minus E1. Okay. So what it is? Minus 1, 1, 0. Well, this is nothing but minus 1 into 1 minus 1, 0. That is 0 into 1, 1, 1 into means scalar multiplication plus 0 into the second vector plus minus 1 into the third. So what will be your matrix, guys? Their matrix will be, you take, write it column wise all entries. But you have written 1, 0, 0, 1, 0, 0, 1 by 2, minus 1 by 2, 1 by 2, and this 0, 0 up. So this is your desired matrix of linear transformation from this new weird basis. Thank you very much.